Thank you, Zach. I'm Isabel Gauthier. I direct the Object Perception Lab at Vanderbilt University, where we do research on visual perception. And so I hope you enjoyed the movie. Yes? Yes. It's kind of a difficult act to follow. And it's going to be a little bit of a different tale. But I'm really, truly delighted to talk to you guys today, to have a chance to explain that, the kind of basic research that we do in my lab relates to a lot of the things that you may care about. So if you're here tonight, you're probably the kind of, curious person who enjoys arts. Maybe you're curious about science. And so if you're here, I want to recommend that you check out this site, The Conversation. Some of you may know of it already. It's a really great source of fun, reliable information written by experts. And so, for instance, last year, I got a chance to tell the story of how people in my lab discovered that people who are colorblind are less likely to be picky eaters. And that is not today's story, but the great thing about following the Baron is that there is no amount of digression I can do that will exceed his own. So anyways, it's just a plug for a really good source of information about science. And so what I want to talk to you about today is how we really see the world differently. Right? But before I do that, I want to start by reminding you or letting you know that vision scientists have known for a long time, and I've demonstrated in a lot of work, that all of us are very limited in the way that we perceive the world, surprisingly limited. So, for example, if you look at a scene like this, right? And there's a lot going on here. And if I, let's say, ask you to look for a watermelon, you might find it right here. And as you pay attention to the watermelon, you might not see other things that are in this scene. You might not notice, the giraffe or other things in there. So our attention when we look at a complex scene like this is limited. That may not surprise you too much. Now, if I ask you to look at this scene and detect a change that is taking place between the two images, some of you can raise your hand if you see it. Don't tell your friends. So I see one hand, two hands, three hands. It's very slow. It's a pretty obvious big difference that is taking place between these two. And a lot of you are not seeing it yet. So let me just pause it. So here it is. Right, so without the blank in between, you can see it up here, right, this thing. So again, surprising limitation of our visual attention. That's not our work. That's work that a lot of other people have done, but it affects all of us. Another way that our perception and memory is limited is that we tend to remember the gist of what we've seen, not the exact details. So for example, you may remember that there was a biplane in the beginning of the movie, but you may not really remember which of these two planes it was, right? So just remember a biplane. If I show you an image of the Baron and I ask you whether you remember the pipe that he was using when he was on the boat that he took from the moon to the Earth, you might not remember that pipe very much. In fact, you might not notice that this is not the Baron at all. This whole image is it's just very different. This is what you saw. But this has the right gist, and so, we kind of have a hard time sometimes picking out the details and remembering all of that. So we all have these sorts of limitations. But so we have limited attention, limited memory, and we also know that we don't all see exactly the same way. Some of us need glasses, and some of us are colorblind and less likely to be picky eaters. But there's more to it than that, and there's some individual differences in how we see objects that my lab has been studying. So when we started this work, the first thing I wanted to know was what people out there, not scientists, thought about these differences. And so we did a survey. We asked 100 people to think about different abilities. So we told them, okay, so what if you had to learn a new language, or you had to learn to match fingerprints, or you had to learn the codes on all these produce like you have to do when you work at the grocery store, or learn to identify cars, learn a new math skill, or learn to identify mushrooms. So a bunch of different skills. And we said, what if you're really good at one of them? Do you think you're good at any of the other two? So any of the other ones. So they were kind of doing comparisons and thinking about, whether being good at one of these things predicts being good at another one. And when we saw the result, what we saw was that they grouped the skills in this way, which may not surprise you. So we have here what we would call kind of general intelligence, right? So we've known from a lot of research that people who are good at learning languages are also kind of good at learning math, and their memory is pretty good. Now, there are differences, but in general, that's what we call general intelligence. And those people put those visual skills, those visual abilities separately. The other thing that they told us in our survey is that they expected, well, they all agreed that we differ quite a bit in cognitive skills, right? This is something that is well known. But they thought that people were probably less likely to be different in their visual skills. And we thought that was interesting. We thought that might be wrong. Now, individual differences has been a very important contribution in psychology. And one reason why general intelligence has been of interest is that it predicts a lot of different things, right? So it predicts not only obvious things like how good you are at problem solving or acquiring languages or how well you do in your job, but things like creativity, emotional intelligence, tolerance for ambiguity. So that's really interesting. But what about those visual skills, right? So that's what we were interested in. We were interested in whether the person who would be the best at learning the difference between these two little guys, right, who you might see them at your bird feeders sometimes, would also be really good at learning to distinguish maybe a true moral from a false moral, or maybe a good person to learn to identify the difference between, in brain scans, between, let's say, a stroke and a brain virus, right? So those are all important decisions, and we didn't really know that much about how people differed for all these skills. So I asked my graduate students to get to work and figure this out, and they don't actually. This looks like I have them in a bunker, working, but they actually look like they're a lot happier. And yes, and so they got to work on all of this, and they created a lot of tasks. And one of them, if you did that demo that we had, out there, the code, we encouraged you to try this. It's okay if you didn't, but if you did, it's one short demo that's an example from the kinds of tasks that we use to study visual abilities. So if you didn't do it, the task looked kind of like this. You saw one object. It's a novel object, and that's because we don't want to have people who know more about birds or know more about mushrooms, doing better just because of their experience. We want to start everybody on the same footing. So we use these artificial objects. Then you saw a mask, and then you saw 3 objects, and you had to pick which one was one of the one that you saw, and they were going really fast, and there was noise, and it was, it's a difficult task. So if you did this, you may remember your score. And so when we study individual differences, we compare, somebody's scores to everybody else's score. So if your score was, most of your scores would have been between a 62% and a 76, right? So if you're at 62%, this means that 25% of the people do worse than you. If you have a 76, there's only 25% of people who do better than you, right? Now, if you have, a score of 83 or 87, like you're really on the top. So now, if you have a great score like that, you can celebrate, you can brag, but if you don't worry too much, because this was a very short test, and as you may realize, you were doing it on your phone, and there's a lot of factors that would influence your score on a test like this. When we study this in the lab, not only do we get a lot more trials and we have people in more controlled conditions, but we also want to have people do a number of different tasks so that we can get a sense for how they do, how their visual perception operates in different conditions. So we might have a different task where you have to memorize, let's say, 6 novel objects. Again, you've no experience with these things, so you study them, you memorize them for maybe 20 seconds, and then we would have a series of trials in which you see 3 of them, you have to pick which of those is one of the 6 that you have seen, and it would keep going like this. So it's more of a memory test here because it's not, always within the span of a trial, but it's like always the same 6 objects for this whole task. Or we might have other tasks where we show you these kinds of objects very briefly, and you have to pick which of these 3 is different, right? And that would be very, very difficult. So we have lots of different tasks like this with novel objects. Now, when we get everybody's scores on all of this, what we end up with is a big matrix of data. We love data. And so we have, different people, different tasks, a lot of numbers, and we crunch all of these numbers through really fun statistics, and we get models. The details here are not very important. What this shows is we're using many different object categories. The squares are the little tasks that we use. But this guy up here, this is our general ability for object recognition. It tells us that most of the differences between people are actually explained by this factor that we call O, which predicts how well you're going to do in a lot of different tasks with a lot of different categories. And as I said, we measure this with novel objects so that there's no big advantage if you have a lot of experience. But we've also done quite a bit of research showing that the ability we measure with novel objects also predicts how well you do in tasks with familiar objects, so things that you're more familiar with that might show up, in a fun movie like the one that we've just watched. So we call this ability, again, we call it O for object recognition. And once we discovered it, a lot of questions came up, right? So one of them was whether O was only visual. We also were curious whether we could find a marker of O in the brain, because we also study the brain in my lab. We were interested in whether artists or people who have experience with art had a higher O, whether people with a high O also were really smart generally, or it was not related. And then we also wanted to know how this could contribute to society. So I'll just give you a glimpse of the answer to these questions that we asked without too much of the details. We did study, so one question was whether O is just visual, and we did create a lot of tasks that were in other modalities. So for example, people come to the lab and they recognize objects by touch. So we do use 3D printing and we create these objects, and then they do these tasks with a curtain so that they can't see them, and they make these judgments, and so we can measure how good they are at touch. And we also made tasks that were auditory, where you had to recognize the songs of birds, or you had to recognize the person who was laughing in 2 different clips. And so when we do this, what we find is that these abilities that are not visual are highly related to visual O. So O is not just visual, but tends to be more general perceptually. The other question was where in the brain might O be? And so we use functional MRI to scan the brains of volunteers and watch. I could not resist. This looks like this was made by Karel Zeman. To look at the brain activity during these tasks. And so this is a summary. This is the brain of an average participant, and it's inflated so that we can see all of the in the middle of all those fissures that make it hard to see the surface of the brain. So it's inflated and kind of on its back. And what you're seeing here is visual areas. And these visual areas that are, some of them are not visual, but these here in the back of the brain are known to be really important for vision. And those in color are the ones that are correlated with the O that we measure behaviorally in the lab. So it's expressed through a lot of the visual cortex in the brain, and that suggests it's quite of a general ability. I also said, our artists, people with a higher O. So we created a survey where we had many questions where we measured people's experience with visual art. So whether they had formal training, whether they spent a lot of time producing, practicing, viewing visual arts, whether they thought they could say a lot about a piece of art that explaining why it would be interesting. So we measured all of this, and what we found was no relationship at all to O, right? Now, I want to be clear. What we measured was not the quality of people's art, right? So we weren't really measuring that. We were measuring just how much people were consuming or producing or spend time thinking about this. So someone like Karel Zeman may, in fact, have a really high O. The kind of visual creativity that's evidenced in this movie is hard to match. And this is a question we haven't really answered. So that's for any of you who might want to be interested in doing a PhD. So the other question I mentioned was whether having a high O means you're generally good at everything, just like the general intelligence that people have been measuring in psychology for a long time. And so we studied this, measured people's intelligence, measured their O, and what we found is that they're not the same. They're not strongly correlated, right? So this means that you can be really smart with math and also be a really good birdwatch, but you don't, they're not, it's not necessary. So you might have one or the other or both or none. So when we study O, we're also interested at, figuring out what does it predict. And we found through a number of studies that people with a higher O ability were better at tasks like learning to spot a tumor in a chest x-ray, learning to categorize these white blood cells as cancerous or not, and even learning to decide whether a face was real or created by AI. So those are two pairs of faces, and for each pair, one of them is real, one of them is AI. This is a very, very difficult task. Actually, I don't have the answer. This is the real face. This is the real face of the two. So it's very hard. But people with a higher O are better at this than people with low O. So we're always interested in thinking about how O can contribute, or understanding an ability like this can contribute to society. So as I suggested, it predicts many important behaviors. And so it might be useful in career placement, especially if you're going to invest in a very long training or a very expensive training. It might be useful to know who's going to do better when you start. It may be useful for expert rankings in different areas to kind of judge whether somebody's eyewitness testimony is more likely to be reliable or not. In general, one of the reasons I'm really interested in this kind of individual differences is because in this society, we measure people a lot, right? And we measure them with great consequence. This is a plot showing the percent of students scoring above 1,300 on the SAT by income group. And what you can see is a very, very strong correlation, right? And SAT is pretty close to an IQ test. So, those are the kinds of measures of cognitive skills that are used quite a bit in society. And so measuring something like visual abilities, which is not fully correlated with cognitive skills, kind of offers us a chance to discover how other people may shine who may also excel in a number of really important occupations. And so there really is value in kind of learning about these other abilities. I'm going to stop here. Thank you for your attention, and see if you have any questions for me. So.
Ask if there's not a strong correlation to intelligence or art, visual ability. Is this something that you think can be improved over time, or is this something that's static, determined at birth?
Yeah, thank you for this question. It's really, it's an important question, and what we know is that when you train someone in a visual task, right, clearly experience is very important. I don't want to say that experience is not, right? So if you train someone to recognize mushrooms, you're going to be doing better with mushrooms, but it doesn't generalize to other categories. So experience tends to be specific to what you're training with. So if you're training in a medical domain, you're going to get really good at this. Now, if you're someone who can get this training and get very good at the medical decisions, you might also be really good if you go get the training and learn to recognize birds, right? But you still have to get the training in these different areas. At this point right now, we don't know of any way to change something like, across the board so that your performance for all the different things that you might want to learn gets better. It doesn't mean that it's not possible, but we don't know.
First of all, I thought it was a very fascinating presentation. Thank you very much for that. I'm very curious, that exercise that we did with that code you provided, I'm wondering if there's a memory component to that. So let's say I'm about to do this same thing again. Now that I know what you're going to show me to an extent and I'm more familiar with the exercise, have you done any studies on whether I'm likelier to do better this time, or am I going to get a fairly similar score because memory doesn't really factor into it at all?
Yeah, thank you. That's a very good question. There is a memory component to it, and that's one reason, and memory is part of general intelligence. So when we measure O, we make sure to have a range of tasks, and some of them depend on memory more than other tasks. But you're right, if you've seen, I said we use novel objects because nobody knows them. Once you've seen a certain category of novel objects, if you are tested with the same ones again, you're going to do better. We have done studies where we bring people back a month later and do the exact same task, and what we find is that the ability does not improve and is extremely well correlated and stable across 1 month. So that's a situation where you may not remember exactly the object. You might see I remember those pink things, but you won't remember the exact guys. So it would be unfair to test you right away. You'd probably be doing better. Like right now, we wouldn't test you in those conditions. So your insight is correct.
One thing that threw me when I did the test, is that it's spatial, like it's three-dimensional, and I was not expecting that.
Yes, yeah.
I mean, obviously that was a conscious decision. Have you done the same thing with just like two-dimensional?
Yeah, so
shapes?
That's again a very good question. So this is one short demo, just one task out of many that we use. Many of our tasks do require you to recognize an object even though it might be rotated in space. And what we have also done is measure things like mental rotation, right? Which is an ability that's been studied for quite a long time in batteries of intelligence. And O is different from the ability to rotate things mentally. Usually that's to make a judgment of whether they're the same handedness or not. So mental rotation tasks they seem very similar to what we're doing, but the ability is quite different, and the parts of the brain that are engaged in those two abilities are different too. So, but it does make. Basically, in order to study individual differences, we need people to make mistakes. If everybody aced the test, there would be no differences and nothing for us to study. So we have to make the test hard in different ways. And so that's why those objects are shown briefly, they're rotated, there might be noise. All of these things make it difficult, but there are going to be people who do this task and get a 97% score.
All right, can I ask who got an 80 or above?
Look at that. So it's rare. It's going to be very rare.
We do have a graphic designer here in the front who did 80 or more. No correlation.
No correlation.
Anyone else? 80 plus? All right.
It's impressive.
Can I ask what you do for a job? Yeah. Marketing? Yes. An artist. Okay. So we
So
got
when we say there's no correlation, it doesn't preclude the fact that you could be both at, great at both. So,
I would imagine it helps
It-
in the artistic field.
What do you see as the function of this ability for humans, just in a survival sense, big picture, evolutionarily speaking?
Yeah.
It's interesting that like it's popped up through our childhood, like whether it's Where's Waldo books or in highlights, children have to find the one missing thing. So there's some natural instinct to cultivate this,
Yeah.
and we've maybe far past like the primitive times when this played a bigger survival role. But in addition to researching disease, how do you see it being important in the future?
Yeah. I mean, you just asked like 10 really good questions. So I'm probably going to forget like 3 of them and not answer the other 2. And so evolutionary, it's very important for us to learn whatever it is in our environment that we need to distinguish, right? Like things like the mushroom that you can eat versus the mushroom that can kill you. That's going to be important. And there's lots of examples like this. Face recognition is very difficult. That's something that I've studied a lot in my lab too. And so, if you can learn to discriminate objects, you get, so, in our world, we learn to discriminate cars. We also learn to discriminate faces. We learn to, depending on our job, like when I do brain studies, I have to learn brain anatomy, right? So there's kind of a perceptual expertise in a lot of different fields that so far people were kind of simply ignoring. The idea being that if you were smart, if you were motivated, and you got the right training, everybody could learn this. And what we're suggesting is that it doesn't hurt to be smart and motivated, but it's not enough for these kinds of skills. But experience matters, and I really don't want to leave you with the sense that it doesn't. So one study that we've done is asking whether people who are from small hometowns versus big cities are different in face recognition. And what we find is that people who are from small hometowns have a kind of a shifted distribution, and they're on average worse at face recognition than those coming from large hometowns. And actually, it's a little bit true also for their car recognition. So in bigger towns, there's more kinds of cars and all that. But so this can only be explained by experience, and so there's lots of evidence that experience matters. But within a small hometown, you're going to have people with a small O and people with a high O, and so both of these will matter.